నేను ఇక్కడ చెప్పాలి కదా. లేదు నేను ఇక్కడ కూర్చోండి. సరే మీరు కూర్చోండి. మార్నింగ్.
To all of you. I take immense pleasure in inviting our Honorable Vice Chancellor of Dr. Y.S.R. Horticulture University, Dr. K. Gopal Garu, and today's guest speaker, Dr. P.V. Varaprasad Garu, distinguished professor from Kursey endowed professor. He is from Kansas State University, America. And all my esteemed university officers, Dr. Dhananjay Rao Garu, Director, Industrial and International Programs, Dr. Madhavi Garu, Director of Research and Dean of Horticulture, Dr. Prasanna Kumar Garu, Controller of Examinations, and the Dean PG Studies in charge, and Dr. Ramanandan Garu, University Librarian, Dr. Vijay Padma Garu, Director of Planning and Monitoring Cell. I invite you all to the 25th Global Connect Series program organized by Dr. Y.S.R. Horticulture University. For the information of our honorable guest today, Sir, the Horticulture University was established in the year 2007. At the time of establishment, this was the second horticulture university in the country established. First one is at Parmar University, Shola. So now the university is functioning with 5 constituent horticulture colleges and 4 affiliated horticulture colleges, and 4 horticultural polytechnics, constituent polytechnics, and 7 horticultural polytechnics, and 21 research stations are functioning, sir, under Dr. Y.S.R. Horticulture University. There are total 41 institutions working on Dr. Y.S.R. Horticulture University across the state. This is the state university with headquarters at Venkatramanagudam, that is near Tadapallegudam, very famously known. That is in the West Godavari district, the rice bowl of Andhra Pradesh. Sir, under our dynamic leadership of our Honorable Vice Chancellor, many programs have been taken up to fulfill the the requirements of the students, staff, both the teaching and non-teaching staff, and also all the supporting staff working in Dr. Y.S.R. Horticulture University for their well-being. And we have taken many activities, education, research, and extension to streamline particularly to improve the quality of the education and research, yes, and also the extension activities in our university. We have so far released nearly 38 varieties from the center, comprising all fruits, vegetables, plantation crops, spices, and all. All of them were approved by Central Varietal Release Committee and also State Varietal Release Committee. We have bagged many national and international awards from reputed organizations. So far, I think we have covered, signed the 84 MOUs with nationally and internationally reputed organizations, and we are moving well with them, particularly in the field of student exchange program to conduct strategic research for the benefit of the PG and PhD students. So this is a brief about our horticultural university. I immensely extend my thanks for being with us today physically for this Global Connect Series program. I think one important activity in this program we have included, based on our advice of our Honorable Vice Chancellor, for the exchange of with the Kansas State University. And apart from that, actually the program for today's webinar is role of sustainable intensification, digital tools and artificial intelligence in agri-food systems. So all these activities were included for today's program. On behalf of our Honorable Vice Chancellor and all university officers and all my staff, associate directors of research, associate deans of respective colleges, principals of all polytechnics, senior professors, all the teaching and research scientific staff are also there through online. They will be attending these programs. On behalf of all of us, we once again invite you for this 25th Global Connect Series program. Hello, sir. Thank you. May I now request Dr. Dhananjay Rao, Director Industrial International Program, to kindly continue the program.
Thank you, sir. Thank you, sir. And welcome to So welcome to Dr. YSR Horticulture University, that exchange of MOU and the 25th Global Connect Series in hybrid mode in collaboration with the Kansas State University, USA, and the role of sustainable intensification, digital tools and artificial intelligence in agri-food systems. Respected Honorable Vice Chancellor, sir, today the chairman for this function, and with his visionary and dynamic, vibrant leadership, we are conducting 25th Global Connect Series, and by arranging international scientists to update the knowledge of knowledge in horticulture to the students and faculty, and 87 MOUs we have signed, sir. Recently we have signed 3 MOUs also with the engineering colleges, SESI, Vishnu, and Vice Technology Institute at Tadapalligudem, and to have a collaboration projects and artificial intelligence, sensor technology, and the latest technologies. And thank you, sir, our Honorable Vice Chancellor, for giving this permission to conduct today's exchange of MOU and Global Connect Series. Thank you very much. Next, today, our guest speaker, Dr. P.V. Varaprasad, University Distinguished Professor, RO, Cruise Endowed Professor, and Director, Center for Crops, Climate, and Communities, College of Agriculture, Kansas State University, USA. And fortunately, I feel very proud that sir is my batchmate at Hyderabad. Okay. When I was studying BSc Horticulture, sir is agriculture. So from Rajendranagar campus. And today is the foundation day for the Horticulture University. So this is the good karmic day for the Horticulture University. And I invite all the university officers, Dr. Madhavi Garu, Dr. Raman Garu, Dr. Vijay Padma Garu, Dr. Prasanna Kumar Garu, and Dr. Srinivasa Garu, Register, and Estate Officer Ramana Garu, Controller Dr. Srinivasa Subramanian Garu, all the university officers and all the associate deans, and all the heads of research stations of KVKs and horticulture research stations, principals of polytechnic colleges, and all the faculty and students. Welcome to this exchange of MOU and Global Connect Series. And Dr. C.H. Nandini, Assistant Professor, College of Horticulture, Vijayawada, and S.B. Ravi Lakshmi, Assistant Professor, Agriculture Economics, College of Horticulture, Anandarapeta, will act as a rapporteur for this today's function. And welcome to this program. And just before going to, I am just introducing the brief biodata of our today guest speaker, Dr. P.V. Varaprasad Garu. Sir is born in Kattur near Uyur, Vijayawada, Krishna district, and obtained BSc Agriculture and MSc Agriculture from Andhra Pradesh Agriculture University, India, and PhD from University of Reading, United Kingdom. He is currently University Distinguished Professor, RO, Cruise Endowed Professor, and Director of Center for Crops and Climate Communities in the College of Agriculture at Kansas State University, USA. His research focus on understanding response of crops to the changing environments and developing best management strategies to improve and protect yields. He has active research, education, and outreach activities around the world. He has published over 512 peer-reviewed publications, 455 journal articles, 57 book chapters, and 5 edited books, which are cited over 36,000 times with the H index of 98 and I-10 index of 330. He is listed in the top 1% of highly cited and influential scholars around the world for the last 3 successive years. He received external funding of over 200 million US dollars for his activities. He graduated 25 students, 15 PhD and 10 MS as major advisor, 70 students, 30 PhD and 40 MS as a committee member, and trained more than 220 visiting scholars from over 15 countries for his research, education, and leadership. He received over 60 competitive awards and recognition from the multiple organizations around the world. He is a fellow of American Society of Agronomy, Crop Science Society of America, and American Association for Advancement of Science. He is a former president of Crop Science Society of America. He was recently elected as to serve as the president-elect 2025 of the Council of Agriculture, Science and Technology. And Sir is adjunct professor, honorary positions, Tamil Nadu Agriculture University, Coimbatore, Tamil Nadu, SRM Institute of Science and Technology, Tamil Nadu, University of Philippines, Sher-e Kashmir University, Agriculture Science and Technology, Jammu and Kashmir, India, Royal University of Agriculture, Cambodia, and Sri Konda Lakshman Telangana State Horticulture University, Hyderabad. And Sir has received many fellowships. 2014 American Society of Agronomy, 2015 Crop Science Society of America, 2016 American Association for the Advancement of Science, 2023 Indian Society of Plant Physiology, 2024 National Academy of Agriculture Sciences, India. And Sir has received many scholarships and awards, and visionary scientist for African Agriculture 2024 from ASA, CSSA, SSA, North America, USA, and a Certificate of Appreciation 2024 Royal University of Agriculture, Cambodia, Lifetime Achievement Award 2024 Bihar Agriculture University, India, and KK Nanda Memorial Award 2023 Indian Society of Plant Physiology, India, Lifetime Achievement Award 2023 from NutriHub, Indian Institute of Millet Research, India, and the Distinguished Service Award 2023 Crop Science Society of America, and the International Crop Science Award 2023 Crop Science Society of America, Global Scientist 2023 Agriculture and Environment Technology Development of Society, India, Working Group Member 2223 US National Climate Change Roadmap Working Group, and Outstanding Unit Award 2022 International Programs KSU, Kansas State University, Ahuja Agriculture Systems Modeling Award, Soil Science Society of America, President 2021 Award, Crop Science Society of America, 22 award also same University Distinguished Professor Group, Kansas State University, International Agronomy Award 2020, American Society of Agronomy, and Commissioner 2021 from Commission on Sustainable Agriculture Intensification. So Sir has received many awards and recognized as international eminent scientist in agronomy. Welcome, sir. Thank you very much for accepting our invitation from Dr. YSR Horticulture University. We are very happy and feel proud that you personally came here and attending in MOE Exchange and Global Connect series. And thank you very much. Now I invite our Honorable Vice Chancellor to do his remarks on this occasion.
So very good morning to all of you, and welcome to our chief guest, Dr. P.V. Vallaprasad Garu. Really, we are very much happy that you are such a scientific field and again research oriented things you have done. That's what we have seen in our CV. And again, the citations, you see, that speaks about your work. 36,000, more than 36,000 citations. So really, we are fortunate to have a talk with you, sir, on one of the important aspects. That is one thing. And second thing, and this is the 25th Global Connect series. And again, this is one of the milestone in our university, because it is 18th Foundation Day of our university. Actually, it was proposed to conduct today, but because of some chief guest agriculture minister's program, southern program. It is postponed to first week of July. So otherwise, we should have conducted in befitting manner in Foundation Day, along with all the other programs. Because of that only, we thought of having this MOU on Foundation Day. But nevertheless, it is one of the good day in our university history. That on 18th Foundation Day, and we are going to sign this MOU with the second or third international university, that were all three from US. And first we had with Harvard, and again another one with the Florida, Texas, and again Kansas State University. Of course, US is the second university. I think Texas we have sent. It is going to complete. Yeah, yes, sir. So really, we are fortunate to have you here, sir. And actually, you know the system, how it works in Indian conditions, university system. You know better because you are studied in AP Agriculture University during 87 to 93. So when you completed your PG program, we entered into service in 1993. When you entered into IAP Agriculture University for UG program, we completed our PG program in the same university. That is the link. And yes, sir, we have so many MOUs, but functional one we have around.
I have joined the college. Joined, I was
We have around 3 dozen functional, effectively functioning MOUs. So here, our aim is to have a MOU, functional MOU, and problem solution type of research works, maybe student research work or collaborative research work between the professors and scientists. So here we have many horticultural technologies which are already there, but now the crops, the interest of the farmers are changing nowadays because of health consciousness and again nutritional consciousness. The crops are changing. Now many new crops are introduced in India. So we know macadamia, we know this dragon fruit, kiwi. So many new crops have been introduced, even lychee, strawberry, so avocado. So we don't have a systematic work on these crops, but they have already introduced. They are there on the farmers' fields. So here we want to go for certain management studies, and again some plant production studies, and again post-harvest management studies, because to encourage this processing for export and all. So in this direction, we are interested to have collaborations, especially in mechanization, and again processing and crop improvement, and again quality improvement, and again other whatever the wherever it is the applicable, this biotechnological and biochemical and physiological aspects in all the crops. So we had MOUs with the local engineering institutes, National Institute of Technology, and we are going to have MOU with even IIT Tirupati also shortly. And again, other institutions here, famous engineering college institutions like Sasi Vishnu, they have a certain good facilities like nanotechnology, and again this geospatial things, and again drone uses and development of standard operating procedures for application of nutrients, fertilizers, and again plant production aspects. So here, this is the what our registrar said. It was a rice bowl. Now it is a horticultural hub, because we can say directly it is a plantation crops hub. Because you see, wherever you see, there will be a coconut, there will be oil palm, there will be mango, and again there will be a banana and cocoa. So these are important crops and perennial crops which are changing the financial status of the farmers. And here there are so many problems also because there were no systematic studies. These are introduced crops, most of them. And again, in other crops also it will already is dragon fruit, kiwi, avocado, macadamia. So there are crops already introduced. So we need to develop technology for farmers, both crop improvement and again crop management and again crop protection and again processing also, processing. So in this direction, we had certain MOUs with these institutions. So similarly, we want to have a research collaborations with international institutions on mainly crop improvement and crop protection. Crop improvement may be utilization of germplasms or development of varieties and commodity-based research works. So, and again, plant production aspects, and again, nutritional management aspects, irrigation management aspects. So we want to have a collaboration on these things, and also processing and mechanization also, because these are very important for the when you see the farmers' cost of cultivation. The cost of cultivation is can be reduced only by mechanization. And again, mechanization may be in the form of introducing tools and implements in from sowing to harvest to the maximum extent. Wherever it is possible, need to be introduced. Otherwise, it is not profitable. So we are interested to have a mechanization, processing, and crop development. These are the important areas. So in this direction, already we started certain things here. So we want to have a constructive research on these 3-4 aspects on horticultural crops, whatever the crop. But because in AP we have most of the horticultural crops are being grown in AP. We have citrus, we have mango, and again we have a wild palm, we have a palmyra, we have coconut. We have so many crops. Even you see in vegetables, so many vegetables are being grown here. Even earlier, so many coal crops were not there.
Mhm.
Now, most of them are introduced. What is
Broccoli.
Yeah, broccoli, spinach. Yeah, so many. So now these are introduced because of their nutritional importance, and again the changing food systems, creating opportunities for further research to have a better nutrition for the growing populations. And again, one side, India is moving towards, of course, organic farming is going on, but natural farming is also introduced in India. Even National Commission for Natural Farming is established. And again, around 2,000 crores have been allocated for this in the government of India. So it's being done as a pilot project in some states, and AP is the number one. So the government of AP is established one NGO, and that is taking care of that. Raitu Sadhikarika Samstha. Under this, they are conducting natural farming system. Most of the natural farming or organic farming are very much useful and useful in case of horticultural crops compared to grains, food grain crops. So, so these are the many opportunities in horticultural crops to work on. So we are happy that the facilities, whatever there in Kansas University, and again the facilities what we have here, we can have a coursework completion here, and part of research work maybe 1 semester or 2 semesters, or if possible some funding agencies from the both sides or from the one side, if they are available, then students can avail this opportunity for successful completion of their PG or PhD programs. And again, in government of AP encouraging the students doing part of research work in other countries. So we have so many corporations in AP. So corporations encourages the students to go for higher part of doing part of higher studies work, mostly the research work. So there are so many opportunities are there. Only thing is we have to find out where it is, and again certain things we should know. And in that, to help here, we have a director of international programs in our university. So they are taking certain aspects, but still it needs to be strengthened a lot to facilitate the students, even the awareness and again opportunities and whatever it is required for going abroad and doing research work and again coming back, or they can settle there or they can go somewhere and they can become entrepreneurs here or there. So these are the certain opportunities, sir. Really, we are very happy that your topic is very relevant. The role of sustainable intensification, digital tools, artificial intelligence in agri-food systems. So these are the terms our chief minister uses frequently. He says deep tech. Deep tech involves all digital, artificial intelligence, machine learning, biotechnology, nanotechnology. Using of all these things for the application part is deep tech. So involving all these things. So I feel it is very important and relevant for our farmers, even for our university staff and students to know the updates and again to gain the knowledge on this aspect. So with this, I thank you once again, sir, for really because most of the times we used to have a virtual talks. Now we are in person. So for that we are very much indebted and happy to have you here. Thank you, sir. Thank you very much.
Thank you, sir. Thank you very much for your remarks and covered all aspects that exotic fruits and vegetables and latest technologies, and to have a collaborative research projects and students exchange and faculty exchange, conducting some programs with the Kansas State University, between Horticulture University and Kansas State University. And thank you very much, sir, Honorable Vice Chancellor. Next, I invite university officers, any remarks on this occasion. So next we can go for the exchange of MOU, the program, and so the MOU, Memorandum of Understanding between Dr. YSR Horticulture University, Venkataramanagudem, West Godavari District, Andhra Pradesh, India, and Kansas State University and Manhattan, Kansas, USA. And just briefly, I will read the Memorandum of Understanding between the two institutes. In accordance with the mutual desire to promote activities between our two universities, Dr. YSR Horticulture University and Kansas State University agreed to the following statement of intent on cultural, educational, and research cooperation. Cooperation and development of activities may extend to any fields and subjects in which two universities may identify shared interest. Cooperation in specific areas may be designated by mutual consent and incorporated into specific additional agreements upon signature by the appropriate university and other authorities. The two universities agreed to the following general areas of interest and cooperation: exchange of scholars and students, both undergraduate and graduate, research collaboration in the areas of mutual interest to both parties, the exchange of professors for lectures and short-term visits, invitation to scholars to participation in conferences, symposia, and instructions, exchange of information, academic materials, and publications in the field of mutual interest, facilitating the mobility of students through exchange and visits between the two universities. Both parties agree that all the financial agreements are necessary to implement this Memorandum of Understanding. Any subsequent agreement must be negotiated according to the regulations of each university and depend on the availability of funds. Both parties recognize that this Memorandum of Understanding establishes a foundation of mutual understanding and interest and does not itself entail any financial obligations for either university. If both universities select to enter into a research collaboration, the parties shall discuss in good faith in terms of conditions of such an agreement and shall endeavor reach a mutually acceptable set of terms and conditions to govern such a research collaboration, including terms and conditions related to funding, scope, and intellectual property created during the course of such research. This document is in no way intended to create legal or binding obligations on either party. It serves only as a record of the parties' current intentions to enhance the relationship of institutions going forward. Before any of the activities set out in this Member of Understanding are implemented, the university must enter into the agreements separate from this Member of Understanding with each other, which will details in a specific form and the content of the activities and address the responsibilities and rights of each university in relation to those activities. The universities agree to negotiate the terms of any such agreements in good faith or for the purpose of enhancing the relationship of the institutions. On behalf of Dr. YSR Horticulture University, Dr. Kurupa Gopal, Vice Chancellor, and on behalf of Kansas State University, Dr. Richard H. Linton, President, and witnesses from the Horticulture University, Registrar Dr. V. Srinivasan Garu, and Dr. K. Dhananjaya Rao, Director of Industrial and International Programs, and on behalf of Kansas State University, Dr. P. Varaprasad Garu from Kansas State University. Sir, now we will exchange and sign.
Yes.
Okay. Okay, Richard.
Thank you.
Easy one, sir.
Okay.
May not be in the US.
One second. Thanks.
Thank you.
Thank you, sir, for exchanging MOUs between Dr. YSR Horticulture University and Kansas State University. And it is a wonderful day, and on the foundation day for Dr. YSR Horticulture University celebrated here. And now I invite our guest speaker, Dr. P.V. Varaprasad Garu, University Distinguished Professor, RO Endowed Professor, and Director, Center for Crops, Climate and Communities, College of Agriculture, Kansas State University, to give talk to our students, faculty, and all university officers in the presence of our Honorable Vice Chancellor.
Thank you. I was just thinking, First of all, good afternoon, everyone. It's truly my privilege and honor to be here at Dr. YSR Horticulture University. I would like to first thank Honorable Vice Chancellor of this university, Dr. Purva Gopal Garu, for giving me this fantastic opportunity to come in person and talk to many of you. And I would also like to thank the registrar of the university, Dr. V. Srinivasan Garu, and also the Director of the Industrial and International Programs, Dr. K. Dhananjay Rao Garu, for initiating all of this talks that maybe a month, 2 to 3 months ago. And I'm so glad that we are finally able to exchange our memorandum of understanding between the two universities. And also would like to thank all the university officers who are in this room, and also many of the students and the faculty and other leaders of the university who have joined us online. Hopefully you're able to hear me. And if you have any questions, please do put it in the chat box, or we will have time for discussion at the later point of time. But I also wanted to first convey the greetings of our president, Dr. Richard Lincoln, to you. I'm just representing him and our Kansas State University in this place today. So now I will talk about this particular topic, which is the role of sustainable agricultural intensification, digital tools and artificial intelligence in agri-food systems. And I've given one of the Global Connect talks a few months ago, but that was through online version while I was at Kansas State. And that talk was more focused on impact of abiotic stresses, particularly looking at high temperature stress and some of the other climate change factors, how it impacted the horticulture of crops. So that was very focused on horticultural crops. But now I'm going to make it a little bit more generic, because all of these innovations and the technologies, which I'm going to highlight in the next 45 to 50 minutes, are highly relevant and can easily be translated into the horticulture crops. So, and I'm glad that the state of Andhra Pradesh, as Honorable Vice Chancellor mentioned, that has been or wanted to be the leader in digital agricultural and artificial intelligence. And that's fantastic. And I do think that this is really the need of the hour. And there are a lot of technologies which will be useful for horticulture and agricultural crops. That's why I talk agri-food systems, because we don't want to separate horticulture from agriculture. Because whatever we do, whether it is grain crops or horticulture crops, at the end of the day, it's all food crops. So that's why I'm trying to use the terminology agri-food systems rather than agriculture or horticulture in specific. So in the next 45 to 50 minutes, I'll be highlighting some of these items. I'm really honored to be here in person. Okay, this will be the outline of my presentation. First, I'll introduce you to Kansas and Kansas State University, and then I'll talk about the global challenges and need for innovation in agri-food systems. Then I'll give you the current status of Sustainable Development Goals and what are the current yield gains and what are the hidden costs of agri-food systems and the greenhouse gas emissions. Then I'll introduce you to a systems platform, which I call as Sustainable Agricultural Intensification. I'll provide you what that means, what are the goals, and what are the specific components of sustainable agricultural intensification. Then I'll give you an overview, a quick overview of Sustainable Intensification Innovation Lab, because Dr. Honorable Vice Chancellor mentioned the need for mechanization, need for crop improvement, need for processing, need for crop protection and crop production, and also many other things. And that's what we have been doing in our sustainable intensification on both horticulture and agricultural crops. I will give you an overview. But the most importantly, after that, I thought it would be good to highlight at least some innovations which are directly addressing food, nutrition, climate, and soil security. And I assume that it was going to be about an hour or 45 minutes. So I'm only going to highlight 15 innovations in the space of sustainable ag intensification, and also 10 innovations in the space of digital and artificial intelligence tools. Considering that we have a very short period of time, I thought I'll be able to cover this in about 40 minutes or 45 minutes. Therefore, I just wanted to give you 25 innovations, which are very broad and can be used for any of these crops which you're working. And finally, I'll conclude and provide a summary of part. But before I go into the details, this is what the map of Kansas is on your left, and right in the middle of, map of USA, and right in the middle of that is Kansas, the item which is lightly purple color in the center. So it's a geographical center of US. And when you look at the state of Kansas itself, which is on the right-hand side in a rectangular form, Manhattan is the northeastern side of the state. And then a little bit about Kansas. Kansas has a population of about 2.9 million people, and its economy is primarily based on agriculture. And the second one is space or aviation or animal livestock vaccine. That's a primary economy. In terms of cropland, we have about 28.2 million acres, and only 2.7 of that is irrigated. So a lot of dryland agriculture or rainfed agriculture is there. And if you look at our commodities, Kansas is number one in wheat. About 26 to 27% of the total US wheat production comes from Kansas. Sometimes we are between 20 and 25% of the total US wheat comes from Kansas. And we are number one in sorghum production. About 60 to 65% of the total US sorghum comes from Kansas. And now a little bit about Kansas State University. It's a first land-grant university established in 1863, after the Morrill Act was signed. And there's also another importance of Kansas State University for India. It has a very strong collaboration right from 1955 till today.
Yes.
And it was Kansas State University who established the land-grant university system in India. And former name Andhra Pradesh Agriculture University was established by Kansas State University in 1963 or 64. So that's really nice for me, being a graduate of Andhra Pradesh Agriculture University, to go back to Kansas and then bring back this collaboration after many, many decades. So I'm really excited about that particular opportunity. And then if you look at Kansas State University College of Agriculture, it has about anywhere from 2,000 to 2,200 students. And it is always ranked in the top 6 or top 5 universities in the country in terms of College of Agriculture. And we have about 20,000 students, about close to 3,000 staff, and about 1,300 faculty. And it is in a town called Manhattan. Don't get confused with the Manhattan of New York, that's what typically people say Manhattan that's a big apple. So we do call ourselves Apple, but it's a little apple, which has a population of only about 54,000. So that's probably not even it's probably smaller than this Venkataramana Gunam in that sense. It's a very small, and we call ourselves a little apple. So that's the background of the Kansas State University or College of Agriculture. I'm super excited about this memorandum of understanding, and as we mentioned before by Honorable Vice Chancellor, Registrar, and also the International Program Director, that we want to make this MOU as a functional MOU. It's not just on this display in your office or in our president's office. Rather than we want to make sure that there are some specific activities which we can take up either in terms of student exchange or faculty exchange, or even some research collaboration, or on some publication aspects. We'll certainly provide a little bit more details about that, and I hope that it will be a longer term collaboration rather than just as a namesake. So I do want it to be a functional MOU. So now let's get into my talk. So these are the global challenges which need innovative and intelligent solutions. First challenge is food insecurity. About 830 million people around the world do not have access to food, which is unacceptable, and that needs to be immediately addressed. Nutrition security. About 2 billion people are malnourished, both undernourished and overnourished. And that could be stunting, wasting, or obesity. And especially the children under the age of 5 and women are impacted by this nutrition security. And that's where the horticulture crops plays a significant role to make sure that we are not only providing the calories, but also meeting the requirements of nutrition, specifically micronutrients, antioxidants, immunity systems. After the COVID-19, people are really using food as medicine, food as nutrition. So that's where the horticulture can really provide and be the leader to make sure that we are providing fruits and vegetables which are nutritious, healthy, high in antioxidants, and can improve the immunity of our vulnerable population, especially children and women. So that therefore nutrition security is important. And we're all aware of the climate insecurity. Earth has warmed up about 1.2 degrees Celsius in the last century. And if we go business as usual, it is expected that by end of this century, the temperatures may go up again up to 2 or 2.5 degrees Celsius, unless we do something about both mitigation and adaptation to climate change and keep this global warming to 1.5 degrees Celsius or lower. And those UN climate conventions have been happening, different COP meetings, and I'm hoping that something positive will come out of those. And then we have serious issue of water security, prolonged drought, limited water, and extensive rainfall, flooding is an issue which is impacting use of our crops and both crops of grain crops and horticulture. Soil security, soils are rapidly degrading and soil health is being lost. And also we are losing a lot of biodiversity. And environmental security, serious issues with loss of biodiversity. And then energy security, there's high demand and need for renewable sources. And then, of course, equity and equality is an issue. Access to food, resources, and knowledge is not equal among various populations. So that needs to be addressed as well. So those are our global challenges. And all of these needs transdisciplinary and convergence of sciences. No single discipline can solve these major challenges. And that's where the opportunities for collaboration between multiple universities across the country and around the globe is growing. So when we talk about food security, there are 4 pillars to food security. One is availability of the food. Second is access to food. Third is utilization of the food. That's where the nutrition comes into picture. And also making sure that availability, access, and utilization is available throughout the year. So stability and food sovereignty is becoming a big issue as well. So that's about the food security. On the right-hand side is agri-food systems. I would really like to highlight that when we talk about agri-food systems, it comprises of the entire range of factors and interlinked activities, right from production to transportation, to storage, to packaging, to consumption, to preparation, and also waste recycling. Because in any of these processes, there is a waste that needs to be recycled in the process itself. Therefore, we need to be looking at the whole system rather than any component of that. And especially as students and faculty should be aware of this, because we often limit ourselves to the only production piece and forget the other components of the agri-food systems. That's where most of the innovation is needed, and that's where most of the losses occur. And we need to make sure that we are very efficient in our systems that way. Therefore, the whole system should be focused on the entire system, and food and nutrition security should be addressed. The next, I would like to highlight a little bit about what is Sustainable Development Goals. Many of you know about them. There are 17 Sustainable Development Goals which were identified several years ago, but the goal was to have in actually 2015. And at that time, we wanted to meet all of these 17 Sustainable Development Goals by 2030. It's right around the corner. We have 5 more years to go. And last year there was last 2 years ago, 2023, that was midway, halfway through our goals. At that time, halfway through the timeline, that time only 15% of the Sustainable Development Goals were on track, meaning that 48% or 37% we didn't make any significant progress. Last week, or I think a couple of days ago, the new report has come up. I wanted to update those numbers, but I didn't get a chance to look at that report. It just came out, I think, yesterday or day before yesterday. And I'm really excited to see what we have done in the last 2 years. But I doubt that there has been significant progress made in the last 2 years. So numbers may be in a positive direction, but not so much. And many of the research work or activities which we do in agri-food systems are directly impacting many of the Sustainable Development Goals. Again, it will require convergence of both biophysical and social sciences. Next, I would like to talk about relative yield gains, and these are for grain crops. It will be nice to see what we have done in the horticulture crops, the key horticulture crops, specifically when you were mentioning about this key horticulture crops of this region. It will be nice to see what yield improvement have been made in the coconuts and cocoa, or in banana or in mangoes over the many decades, and see and look at the demand and see how much more yield improvement on an annual basis needs to be done. So if you look at that visual from 1960 to 2020, past 2020, the relative yield, that shows you the yield over the time. And the right side figure gives you the relative yield gain, meaning from 1 year to another year, how much percentage of yield increase is happening. So if you look at 1960, for most of the crops, we had about 3% increase every year. But that has now come down to closer to 1%. That means that we're not making significant yield. In the overall term, it's increasing, but year to year, we're not able to increase as much as we did in the early 60s. And I believe that has to be turned back in the range of 2 to 3% again, to be able to meet the demand in the growing population, which says that we have to increase the yield by 60%. So that curve needs to be changed. And I do believe that with significant innovations, particularly in the speed breeding, genomics, and also phenomics and artificial intelligence, we might be able to reverse this declining trend of yield improvement, specifically for the crops which are important for grain and also for the nutrition piece, which is where the horticulture crops come into the picture. Now, this is a very important report, and I believe that specifically all of you who are working in horticulture will really appreciate this. This report came out 2 years ago, I believe, and it was quantifying the impact, hidden cost of the global agri-food systems. This is often overlooked because we only talk about, okay, how many people are malnourished or undernourished or do not have access to food, and we stop there. But there is several indirect costs or hidden costs of agri-food systems which are related to agriculture. So if you look at on the left-hand side, that hopefully I'm not able to see the screen that well, but I do have some numbers in my mind. I'll be able to tell that. So the total hidden cost of agri-food system is about $12.7 trillion, which is a lot. And then of that, 73% is associated with health. 73% of that 2.7, so approximately about $10 trillion is associated impact on health system. As you know, in India, pretty much it is, the report says that, not this report, another report says that about 50 to 60% of Indian population will have diabetes at some point of their lifetime. It's a matter of time, whether you are young now, but before you hit 60 or 70, pretty much 70% of the Indian population is prone to diabetics. And there's also issues with cardiovascular diseases and obesity and everything else. And then environmental cost of that is about 22%, and the social cost is about 4%. So when you talk about this health, and diet is directly related, meaning that having nutritious, healthy, safe diet, and that's where horticulture really comes into picture. So health is primarily related to the diet, nutrition, and environment is primarily related to use of fertilizers, especially excess nitrogenous fertilizers, and climate and water use. And the social aspects is related to the poverty related. So it's remember, it's 73% of that is health related, and then only about 22% is environment and 4% is social. And this will again require transdisciplinary research to be able to address this challenge. This one is greenhouse gas emissions scenario sector-wise. And if you look at energy, is the main energy sector produces the most greenhouse gas emissions, but also contribution of agriculture or agri-food systems is there. About 18.4% of that comes from agriculture. But also agriculture can be a solution as well. So especially if you're able to develop innovations which can allow us to climate adaptation, mitigation, resilience, and using some of the sustainable agriculture intensification principles and using circular bioeconomy systems, we would be able to minimize those greenhouse gas emissions. And I believe that of all these sectors, whether it is energy, agriculture, transport, and fuel and everything else, the only agriculture sector can be a net negative in greenhouse gas emissions. All other sectors can be neutral. They can neutralize, meaning that however they're producing the greenhouse gas emissions, they can use alternative ways to negate that. But agriculture is the only one which can have a net negative system through both, especially through sequestration, both from terrestrial sequestration, because forests and crops and any living plant absorbs carbon dioxide from the atmosphere, so it can actually minimize the carbon dioxide from the atmosphere. And also the soil carbon sequestration is huge through making sure that this carbon dioxide is converted into the organic matter. So remember that the agriculture is the only sector which can be net negative in terms of carbon greenhouse gas emissions, particularly carbon dioxides. And now, how do we solve these issues of food, nutrition, climate, soil, environment, energy, and inequalities? That's where the systems approach or the concept of sustainable agricultural intensification comes into picture. And it's a broad terminology also, although it was discovered or it was named in mid-1990s by Professor Jules Spritti. But now it has gained momentum, and it's really making some significant progress in addressing some of the sustainable development goals. So the goal here is to provide access to safe, nutritious, and healthy food at all times to all people from existing farmland without damaging our natural resource and ecosystem. That's the whole goal of this. And I've been using a slightly different modified version of this definition, because existing farmland is very critical, but without damaging the environment, meaning that do no harm principle, right? But we have done enough damage in the last several decades. Not doing any more damage in the next 2 or 3 decades is not going to be any beneficial. So we have to make sure that we are regenerating or rebuilding our natural resources. So on existing farmland, but with emphasis on moving away from without damaging our environment to rebuilding our natural resources and ecosystem health. And that's where some of the concepts of this particular state of Andhra Pradesh, where they are focused on nature-based solutions or natural farming, will play a significant role. So there are 3 components to the sustainable agriculture intensification. First one on your right is the genetic intensification. In the middle is an agroecological intensification, and on your left is socioeconomic intensification. So broadly defining genetic intensification is focused on higher yields, improving the resilience to pests and diseases, improving the tolerance to abiotic stresses and climate change factors, and then also focus on medicinal value, or using both traditional and precision breeding programs are component of that genetic intensification. All aspects of related to genetics, including use of germplasm resources, is very critical component of that. In the middle is agroecological intensification with a farming systems approach, or integrated agronomy is part of that. So integrated soil and water management, integrated nutrient management, integrated weed management, and also efficient agriculture practices and increasing the input use efficiency are components of that. And then on your left is a socioeconomic intensification, which is making sure that there is markets, the development of new markets, access to market, building social capital, creating appropriate policies, implementation of those policies, capacity building, all of those are components of the socioeconomic intensification. And the new tools, whether it's the geospatial tools, artificial intelligence, nanotechnology, use of mechanization, use of precision agriculture, use of microbiome, and also public and private sector engagement and intellectual property rights. Those are all cuts across all of those aspects. And of course, engaging youth, gender, scaling, data science, and communications are critical components. So this provides you a systems approach and a framework to address many of the global challenges which I highlighted at the beginning of our presentations. So that's a big introduction. Now, what have we done what have we done at Kansas State University and my specific innovation lab? I was the director of the Sustainable Intensification Innovation Lab for over 10 years, from 2014 to 2024. And we completed for the next version of this innovation lab, but right now it's on pause. We'll figure out how we can continue. So this is a global program. It's a multi-country with regional partnership. We work across 14 countries around the world. 2 are in Asia, Bangladesh, and Cambodia. And then about 4 of them are in East Africa, Ethiopia, Tanzania, Malawi, and Rwanda. And then in the West Africa, we were working in 5 countries: Senegal, Burkina, Niger, Mali, and Ghana. And in Central America and Caribbean, we were in 3 countries: Haiti, Guatemala, and Honduras. So that's our global presence. And it was a big program. I don't have time to explain to you in our time today, but I would encourage you to go and look at our website, which is provided either on the left-hand down corner of this slide. So it was really a systems program. We had a mechanization consortium with the lead from University of Illinois, and we had a geospatial environment systems consortium and a digital tools consortium at UC Davis, University of California, Davis, and Kansas State University. We had a policy consortium with Rutgers University. We had a soils consortium with the National Fertilizer Development Center. And then we have 4 centers of excellence, 1 in Cambodia, 1 in Haiti, and now currently one in Guatemala. It's a huge program. We funded about 130 scientists from 120 different organizations, and we supported over 300 graduate students in partnership with 20 US universities and 9 CGIAR organizations. So it's truly a multidisciplinary global partnerships. So now I'm going to go a little bit more technical and then give you some specific examples. So before I do that, I want to highlight some of the goals. What are the goals of the food producers? Whether it's farmers, anybody who's engaged in agri-food systems, the ultimate goal is to increase yields, to make sure that they have high net income, make sure that they have minimizing the risk, and they are enhancing the nutrition and health and better livelihoods of people. That's the goal of any people or any person who's involved in food producing. Same time, so what are the needs? Right? That's what their goals are. What are the needs? The novel technologies and quality inputs, methods to improve the efficiency, better markets, policies, and access to credit, right and stable prices and value addition, and then timely access to knowledge and information. Doesn't matter which farmer you ask, agriculture, food, horticulture, plantation crops, doesn't matter. So these are the 2 which really cuts across the needs of the producers and what are the goals of the producers are. And then as a research university or as a university, we need to make sure that we are providing evidence-based innovations, access to quality data, and that's where the digital and artificial intelligence tools will come to meet these goals and needs of our people who are engaged in our food production. So targeted approach is required to meet the individual needs and the producers based on the typology of the farms, which is both biophysical and socioeconomic conditions of that. So now that said, now I would like to give you some selected examples of sustainable agricultural intensification first, and then later on some of the digital tools and artificial intelligence. Because of the time constraint, I chose 25, and I'm right on time. I have about 35 minutes, and I believe I'll be able to tell 2 minutes or 2.5 minutes for each of those, and then we'll have plenty of time for discussion. Before that, I would like to put a disclaimer because some of these examples are selected from literature, and due credit, the sources have been identified and acknowledged in those slides. Some of the research is our own research, but because I wanted to make sure that I'm covering a broader perspective, not just talking about my own research, because it's the benefit of the students and faculty, and as a university where you want to go. So I do want to put that disclaimer over there. So here we go. Number one, and they're not in a particular order. It's just that I want to make sure that I'm covering all those three components: genetic intensification, agroecological intensification, and the socioeconomic intensification in those. So first is speed breeding technologies, and that applies to both grain crops and also horticulture crops. We all know, and in every slide there is contribution, or where I put the information is that on the left-hand corner you see a slightly highlighted title, in this case global. That means these innovations are applicable around the world. It's not specific to that particular country or particular organization. Of course, it has to be adapted or redeveloped for your local needs, but at least the innovation itself is applicable around the globe. So each of those slides will have that information typically on the top left, but it has been highlighted. So if you look at traditional plant breeding, it takes about 14 years to release a new variety, because it's germplasm screening, selection, back process, all of those time. And by the time we release the new variety, it's already lost the relevance, especially if it is pests or diseases. So by the time you release this variety, the pests have self-modified themselves, and then so it's therefore we really need to improve that time from initial selection to the release of those varieties. And that's traditionally we take that. And the new approach was the shuttle breeding, meaning that you're able to, because your environment is not suitable, so you grow another place where this environment is suitable. So you can grow two crops. And then came the greenhouse technology, so where you can control the environments, specifically the greenhouses, and may be able to produce 2 or 3 crops in a year. But the new innovation is the speed breeding. Speed breeding is a technology where you're able to control 2 aspects. One is temperature and affordability, because those two will allow you to shorten the life cycle and also make sure that it flowers. So if you have this speed breeding technologies which can minimize the time frame from seed to seed, shortens it, and that way you can produce 2 or 3 crops in a single year. Because for breeders, they need 1 or 2 seeds to just take it to the next generation. So therefore, the speed breeding is very relevant. Initially, it was identified by scholars in Australia, but it's now being used around the world. And then that's one aspect. And then associated with that speed breeding is also now you have access to double haploid development of double haploids or tissue culture techniques or transformational techniques where you can hasten the breeding process. So that's speed breeding. And then we all know about the CRISPR-Cas9 or gene editing technologies. So there are Express Edit now, combine the genome editing with CRISPR-Cas9, or another cassette is CRISPR-CPF, and there are many others which are coming up. So if you can couple the speed breeding, which I was talking about, and the rapid gene editing, if you combine those 2 systems, you can further enhance the speed of developing new hybrids. So there are multiple ways we can do that. There are some specific details, Express Edit approach, and then combining the genome editing tools, we can hasten that. So and this is all genotyping, right? But you also need to have appropriate phenotyping to make sure that you have rapid phenotyping with the drone technologies and the satellite imaging. Now you can also have a rapid phenotyping. So combining this genotyping and phenotyping, you'll be able to use predictive modeling or stack multiple traits to enhance multiple tolerance. So that's that one. Now, so those were the more primarily the genetic intensification components. And this visual here shows you the farming systems. I would like to emphasize this need for farming systems. Globally, there are 72 farming systems. That means, what does a farming system mean? Farming system means that based upon your biophysical conditions, soil condition, temperature condition, rainfall condition, photoperiod conditions, and the light levels, which are the most suitable crops or farming system which can be grown. If you are growing an unsuitable crop in a farming system, it will not be efficient, the productivity levels will be lower, and it also causes environmental damage. So there's a lot of information about the current farming systems around the world. And farming systems, I'm talking farming systems, not cropping systems, or not agricultural systems. The crops are very different. Whenever you say farming systems, crops, both annual, perennials, horticulture, grain, even grasses or forage crops are included. And then livestock, both cattle, meaning the cows and the swine and goats and sheep, aquaculture, both feline aquaculture and fresh aquaculture. So that's what captures the entire farming systems. So we need to make sure that we are producing the right crop in the right farming systems. And in this visual, I'm just giving you on your right, I just wanted to give you a feel for temperature response of grain crops, because not all crops are equally sensitive or equally tolerant to temperatures. Some crops are highly sensitive and some crops are tolerant. So that's the temperature response curve in terms of harvest index for major grain crops. I believe there are wheat, rice, sorghum, millet, and then dry bean and peanuts and cowpea. So if you look at among the cereals, wheat is the most sensitive to temperature, whereas millet, particularly pearl millet, is the most heat tolerant crop. And if you look at the legumes, dry bean is most sensitive, and cowpea and green gram and rural gram are very tolerant to high temperature stress. So if you are producing based upon your temperature conditions and the rainfall conditions, you should be able to choose a selective crop. So now climate resilient and nutritious crop. And again, nutrition is very important. People are getting calories, but they're not getting their nutrition. And last year or year before, 2023, was declared as an International Year of Millets. And when we say millets, it's just not one or two crops. Traditionally, whenever somebody says millet, we only used to think it's pearl millet. But there is more than 16 crop species, starting with sorghum or jawar, or pearl millet or bajra, single millet or ragi, and we have many little millets, foxtail millet, koda millet, barnyard millet, and prosa millet. So it's a millet is a group of crops, and they are very nutritious. They are very climate resilient because the water requirements is very low, and they're also temperature tolerant. So there is an opportunity to incorporate these millets into our cropping systems, but of course there has to be demand for those, and there has to be a market price for those, because now there is awareness of the people, but we need to make sure that there is minimum price of. I hate to use the minimum price because it has to be not minimum, it has to be cost plus 20% rather than the minimum price. So there needs to be opportunities to make sure there are enough market, and the policy and the support price for millets should be there. And again, there is a huge genetic variability in the millets that need to be utilized, especially from the nutrition and health and immunity perspective. So that's that. And then within each of the crops, again, nutrition. We really need to be thinking about that. There's a lot of emphasis specifically in the program called Harvest Plus. They have biofortified nutritious crops and varieties. And these are not GMO. These are developed through traditional selection and breeding processes. And there is enough genetic variability in all of our crops, including horticulture crops, in terms of micronutrients and antioxidants and health benefiting traits. So we need to make sure that we are screening them, identifying the lines which have higher of these nutrients, and then use the traditional breeding program to make sure that trait is translated into that. And this Harvest Plus program was funded by Gates Foundation, UKAID, USAID, and also there are some other entities which were involved. So we now have high iron beans, high iron cowpeas, high iron lentils, high iron pearl millets. And in terms of zinc, we have high zinc wheat, high zinc rice, high zinc maize, high zinc sorghum. And in terms of vitamin A, we have orange fresh sweet potato, which is high vitamin A. We have cassava, we have maize, we have banana and plantains. So we need to be focusing in those direction. And of course, presence of those in the grain or in the fruit is not enough. We need to make sure that once people eat it, it's bioavailable and it's actually being utilized, absorbed by our system, and it's benefiting that. So there needs to be a little bit more emphasis on quantifying the bioavailability and also actual health attributes that can be attributed to this biofortified crops. And then next is the stress tolerant varieties. We always have new pests, diseases coming in, and we also have new extreme events of drought and temperature and cold and salinity and flooding. So we need to make sure that we're developing new varieties which are resilient to these abiotic and biotic stresses. Here, I just wanted to give you one example of drought tolerant maize for Africa, DTMA maize, which ran for about many years until I think it was 10-year program until 2014, and thereafter, which was converted into stress tolerant maize for Africa because drought and heat were combining together all the time. So not just focusing on drought, but also making sure that they are addressing the heat and also the soil nutrient deficiencies. So they operated in 13 countries, and focused on maize, which was 72% of the maize in those countries and continent of Africa was producing. We released about 184 distinct varieties. Most of these varieties were showing a yield improvements of 50% or more. And in the drought conditions, they were doubling the yields, but also there was no negative impacts under normal conditions. If it performed better in the drought, it was also performing under non-stress conditions as well. So that was a successful program. CGIAR took the lead with support from Gates Foundation and USAID. IATA was involved, CIMMYT was involved, IRRI was involved, ECOSAT was involved. So there was a lot of those opportunities there. And then here we talk about doubled up legume system. And generally we talk about crop rotations, right? We talk cereal, and we always say that rotate cereal crops with legumes, meaning that you rotate your rice, wheat, maize, sorghum with appropriate legumes, whether it is mung bean or black gram or green gram or common bean or groundnuts or cowpeas, because of the biological nitrogen fixation of the legumes, which can minimize the application of nitrogen for the following cereal crop. So that's typically one cereal and one legume. Here you have doubled up legume system where we are producing one of the cereals, whether it is maize, sorghum, millet, and then normal crop of either beans, cowpea, or groundnut. We are introducing pigeon pea because pigeon pea is more perennial and it is taller compared to that of a shorter height crops. So we can have cereal, a tall legume, and underneath the canopy of that, you can still produce your traditional legumes. So that provides multiple opportunities. And some of these pigeon peas are perennial, so they can be kept for a lot of years. So this was very successful in those countries which I highlighted. And some of these could also be valuable for Andhra Pradesh or systems in our semi-arid regions. So the next one is dual purpose crops, meaning that there is always integration of livestock with crops. Those days are gone when the farmers are only producing one or two crops or one crop. There's always some component of livestock, whether it could be cows, could be sheep, could be chickens, or could be aquaculture. So there's always a need for those dual purpose, meaning that you want to make sure that you're not only eating the grain, which is highly nutritious, but also when you are giving the forages or the biomass, when you're feeding it to the cattle, you need to make sure that there is enough nutrients in those biomass as well. So therefore, we are looking at dual purpose crops, grain for human consumption and the biomass for livestock feed, and both are biofortified in terms of iron and zinc. So we have dual purpose sorghum, pearl millet, and cowpea, very popular in West Africa, Senegal, Burkina, Niger, and very relevant globally as well. So those visuals you have this dual purpose sorghum, pearl millet, and cowpea. The next one is agroforestry systems, and that's where horticulture crops again come into picture, because we need to have integration of annuals and perennials is very important. And this visual here, you see that it's not that clear to me, but if you can see that the tree which is which has the cows in there, so that's the peak crop growing season. and the tree is naked. It does not have any leaves, meaning that it is not competing with your crops. So when you go in the off season, the trees have fully flushed leaves. And that is hard time, right? And when you have the trees that is fully flushed leaves, there's always cattle which come and sit underneath it. And it provides organic matter. So it's called reverse phenology. It is not competing with your annual crops, and it provides as a shade to the livestock, which improves the organic matter. And also another thing is that these are perennials with deeper root system, and they hydraulic lift. They move the water from the deepest layers of the soil to the upper layers in the off season, which is now available for your regular crops. And those are tree systems. On your right is the shrub systems. And this is Fiderbia albida of the tree. And then the shrubs are Injurius anagallensis and few others, which are not trees, but they are shrubs, but serve the same purpose. So that's another nice way of integrating perennial crops. And if they are fruit bearing, that's even better. So there could be some opportunities to identify those. The 10th one is perennial grain crops. You may be surprised, why am I talking about perenniality here? Because we made perennial crops into annual crops after 100 years of breeding, and now we want to make sure that we're going back to the perennials. But perennials have a role. I'm not saying that your highly productive land should be in perennial grains. The marginal lands or the lower productivity lands can be in the perennial grains. And if you look at now, we have the perennial rice. Perennial rice, 8 cuts, similar yields, developed by Chinese Academy of Agriculture Sciences, and that was identified as one of the top 10 scientific breakthroughs by the Association of Advancement of Sciences of US in 2022. So now there is a perennial hybrid rice, which produces 8 cuts with the same yield, which is, we're talking about 8 to 10 tons of yield per cut. So 8 tons of yield per cut, 8 cuts perennial, that minimizes a lot of input. So there is that opportunity. And there is also a wheatgrass, perennial wheat, which is marketed as Kanza. And there's a perennial sorghum research going on. So the perennial, I'm not saying that all the annual high yielding rice should be, and other crops should be replaced, but there is a space for that, especially in the marginal and low productive areas where you can minimize the cost of feed, cost of labor, cost of fertilizers, and all of those things. And this is very relevant. This is horticulture crops, actually, all of this. Conservation agriculture practices, the solar power drip irrigation or micro irrigation systems. Because when we talk about natural farming and organic farming, for grain production, it is tough. But horticulture crops, absolutely. Most of the horticulture crops, all of them could be actually produce nature-based solutions. Natural farming is very relevant to horticulture crops, more so than the grain crops, because grain crops, we don't have enough biomass to, I'm not going to go into that debate, but for horticulture crops, natural farming is the best way to go forward. Here we are using conservation agriculture principles with this continuous soil cover, crop rotations, and then no tillage. So those are the 3 principles of conservation agriculture. These are indigenous vegetables and commercial vegetable gardens, complete mulch. That mulch can be locally available mulch, whether it is rice straw, whether it is your tree leaves from your trees, or even from water hyacinth dried from your water bodies. So any available mulch can be put on that so that there's a continuous soil cover, and you rotate the crops, and then drip irrigation systems, and solar power. So that's a nice combination. And on the right-hand side, you can see there's a small bar, which is sensors, meaning that it tells you when to stop irrigation. Over irrigation can also yield a lot of yield loss. It's a simple thing. Whenever they're irrigating, as soon as the soil moisture is saturated, the head pops out. That means, okay, stop irrigation. So you can, it's a very low cost sensing. So that's tremendous, very successful in many of the cases which we are doing. And the 12th one is integrated pest management, meaning that there's a lot of use of chemicals. Anything which you can minimize the use of chemicals will be very valuable. So this is called push and pull technologies, meaning that you can use trap crops to attract the insects, and also another crop which can repel the insects. And here's an example of push and pull technologies in a maize system, where your main crop is maize and your trap crop is Napier grass or Bracharia grass. So this attracts the moths of the stem border. So it keeps the main crops free of stem border. And in between the main crop, there is a legume called Desmodium, and that volatiles repels the pest. So intercrop with plants which repel the pest, and then borders which attracts the pest, so that your main crop is protected. So this is just one example. And to give you another example, horticulture is that marigold. Marigold is often put on the sides to attract the pests, right? And then also ocimum or holy basil is another one. So I'm sure there are multiple of those species which are relevant to some of the horticultural crops here. And then next one is microbiome or use of microbials. And I'm not going to go into the details, but I just wanted to make sure that there is you understand by the concept of broader One Health. When people say One Health, we're oftentimes restricting it to human health and livestock health and environmental health. But all of those begins with healthy soils. Healthy soils will have healthy plants to healthy animals to healthy humans, and healthy humans to healthy ecosystems. So the entire value chain from soils, plants, animals, humans, and ecosystems should be an integral part of it. And we know that soil has its own microbiome, plants have its own microbiome, animals have it, humans have it. So we need to make sure that we're taking advantage of the entire microbiome, which is a very nascent science at this point in time. More research is needed of that. And then the second last one is nanotechnology or nanomolecules. And nanotechnology is used for not only stress management or precision delivery of nutrients and pesticides and biomolecules, but also sensing the stress. So you can sense the stress, you can apply those nanomaterial to increase the tolerance, and then also or even protect before the stress comes in through precision delivery. So there's a lot of opportunities to use nanotechnology and nanomolecules on both sensing and management of stresses. The last one in this is social aspects. So having a technology is not enough. That has to be adopted and scaled by the farmers. So we need to make sure that we are coming up with new social innovations in the communication platforms so that our innovations are available to the farmers. Traditionally, we have been using farmer field schools, the women's self-help group, but there are also new knowledge sharing platforms, targeted communications. This is one of the programs of the FAO, which this is actually in Andhra Pradesh. That's why I was going to show that. So it's there is an opportunity to make sure that we are forming social groups of farmers or producers so that they can collectively work together, and we can also disseminate the knowledge. And in the Krishi Vignan Kendras are doing very health and Dwakra groups. So there's a lot of those in Andhra Pradesh as well, but that needs to be enhanced or increased. So those were my sustainable ag intensification technologies. So I have about 12 minutes or so, 12 or 15 minutes, I guess. So I'm going to give you 10 digital and artificial intelligence tools now. And again, these are also disclaimer. Any mention of the trademarks or the companies or the apps or materials is simply an example and not endorsed or recommended by me or my institution or the organization or the donors which have provided this funding. This is purely scientific exercise, and some examples, or most of the examples, are taken from the literature and I've given the credit to those organizations. I want to give that clearly because I'm not promoting a particular app or a particular company or a particular technology. So it's mostly for the scientific purposes and specifically for the knowledge and the benefit of the students. So now, before coming here, I thought, okay, we all talk about artificial intelligence, but what is the literature behind it? Who is working on it, and what component of artificial intelligence is being taken purely from a research perspective? So I did this day before yesterday. I wanted to do it last night, but I didn't. I was too tired and I slept. So I thought, okay, one day those numbers are not going to change significantly. The first thing I did was, where is artificial intelligence research? So I combined the terms artificial intelligence and various aspects. So first I looked at only artificial intelligence, 7,500 articles. This is in Google Scholar. Then I looked at agriculture, it's probably 6,460. And then I looked at various combinations of where it is. So AI and land use planning, AI and agriculture water management, AI and crop management. Those were the top 6 areas where research is focused on. I did put AI in horticulture, so we have 90 papers saying AI in horticulture. So it's at a nascent stage. So there is significant opportunities to use AI as we move forward in the horticulture sector. So that's just an overview. That doesn't mean anything, but I just wanted to give you where the current focus is. And that, I mean, I don't see that as a weakness. I see that as an opportunity. The fact that there's only 90 articles of AI in horticulture versus there is AI in livestock is 300, and then AI in crop management is 1,000. So there is more need for integration of AI into horticulture. So that's what that tells me. I don't see it as a weakness at all. I see it as an opportunity. So most important is land use, water management, crop management, precision agriculture, nutrient and plant disease, and all of those could be applied to horticulture plants. So that's an opportunity. And then I thought, okay, which countries are doing this? I did this 2 years ago, this exercise, and at that time, China was the leading country which was doing work in artificial intelligence. I'm surprised that last night or day before yesterday, US came closer. So now US has just a little bit 100 more articles than China. So the leading countries, top 6 countries who are emphasizing research on artificial intelligence, and all in agriculture, all in agri-food systems. It's not beyond. I mean, if you look at transport and if you look at other defense and everything else, there is a lot more artificial intelligence going on there. But this is related to the agri-food systems. So US is number 1, Canada is number 2, India is number 3, Australia, followed by Germany and Canada. This is purely based on the published research. There's a lot of research which is not published. That's different story. But again, this is purely based on the availability of the papers in the Google Scholar. So that means it's picking up. India is top 3, and then if the both central government and the state government is emphasizing the need for digital ag and AI, these numbers will really change in the next 5 to 10 years. So that said, that how can I want to first mention how can digital and AI tools help, and then I'll give you examples of specific areas and what are the apps which are available now. So these are the various areas where digital and AI tools can help. Suitability mapping, meaning land use planning based on the soil type and biophysical condition, what that land should be used for, whether it is for commercial buildings or whether it is for farms or whether it is for horticulture or whether it is for grassland or whether it is for crops. So that's what I mean by a targeted value chain. Number 2 is soil information, climate services and weather projections. Number 3 is a targeted agronomic service, whether it is genotype, planting dates, nutrients, water, weed, and pest management. I'm not going to go into the details because of the time constraint, but at least that gives you an idea of what we're talking about. Precision management of inputs, whether seed, nutrient, water, herbicides, pesticides, early detection and monitoring of crop health, and crop chronology and crop growth and crop yields as well. And then monitoring and spread of pests and diseases. If you know that this particular pest or disease is moving from southern India to northern India can be protected before it is done. If you remember locust and fall armyworm, India was able to protect its land when the locust thing came from Eastern Africa to Pakistan and from there. So Indian government was able to take care of it not entering beyond Punjab. So that's what this whole thing about disease and pest monitoring is. Predicting, improving yield and quality, improve access to food and processing and distribution system, early warning system for food shortages or excess, because excess in the market is also not good. Sometimes I was told that price of onions and price of tomatoes, sometimes it's 50, it's low, and sometimes it's 10 times. So we need to make sure that there's enough people are producing and it's not overproduced or underproduced. And of course, timely policy interventions will also play a significant role. So that's how it can help. I can go details, but just to please give you the information. Now I'll just take some of those examples and give you what is available now. We are not talking about what's happening in the future. These are all available now. And wherever possible, I try to see if there is an Indian company or Indian relevance so that at least you can look at them again. I'm not promoting anything. I don't know the legitimacy of those. I just took it from the literature. Some of them I know. So this is a program called Land PKS, ISRIC, and then USDARS, US Department of Agriculture, and then also IFDC, International Fertilizer Development Center. What they are doing is they're taking the images from the satellite and ground truthing from the soil on the ground, and then modeling up and modeling down. And so they're trying to make sure that we are applying appropriate amount of fertilizer at appropriate times. So all the 5 hours or 4 hours of irrigation and water management or nutrient management in that sense. So we have this opportunity to use these tools, provide the input of your geographical location and GPS, and then tie it up with the soil mapping, tie it up with the weather data, and then say what's the best way to manage this particular land. That's land and soil management. And here's another example from Ecosat, which is located in Hyderabad, which they are using identifying what's the best time of sowing based on last evaluation of the last 100 years of rainfall starting date and session, initial date and session, and what is soil moisture and all those things. Now you can actually tell farmers app which will allow the farmers to make sure that they are planting at the right time, because appropriate planting is very important. If it is soil is dry or too wet, emergence will not come up, and making sure that based on your availability of the soil, if you're able to irrigate at appropriate sensitive stages, you should be able to get better yields or protect your yields. So that's some of the tools which are allowing seeding and planting. I'm talking as we progress from planting to harvest. First land use, then appropriate crop, and then how do you water management, fertilizer management, pest management, and the quality. So I'm going in a sequence that way you can get a feel for what types of things are available. So this is going to be critical, where the digital and AI tools are going to be very relevant, especially when you're talking about precision agriculture. Because what are the most cost for the farmers? Seed, water, fertilizer, energy. So if you're able to make sure that you are planting the right amount of seed and not blanket application, if you know the typology of your field, because not all fields are uniform. Even if it is 1 acre, not the entire 1 acre is not uniform. There are some low-lying areas, there are some high-lying areas, some that low in soil nutrients and low in nitrogen and micronutrient deficiencies. So you need to make sure that you're not wasting. Blanket application of irrigation or nutrients or seed is not good. So therefore, if you have this specialized map, then you can target apply those particular seeds. And this particular app is from Geopard. It's Geopard Agriculture. It's a German company, and it allows for precision application of your inputs based upon the topology of the farm. So they show that basically it's variable application rates of all the inputs. They create that map for your field, and then based on that, they give a recommendation so that you're not wasting your resources. So zoning of appropriate zoning of the maps. And then this one is crop growth and health. Same Geopard, where they can actually monitor the health of the plant, because each plant or each crop gives a spectral signature. Based on that, you can tell whether the plant is healthy, or it is deficient in nutrients, or it is having abiotic stresses, or there are biotic stresses. So if they're able to use the monitoring of these crops based upon the imaging tools, now the drones can be applied, and you can take high resolution images. It's not just using the satellite images, but the drones can allow you to monitor plant crop growth and health variable. And then irrigation, because irrigation is very expensive, and this is a company in Bangalore, I believe, Cultivate. And so they are providing irrigation services. And so basically they have in-field soil sensors, and then they are not only in your own field, but also in the neighboring field, and they have access to weather data and then past history. So with that, all the data is stored there, and then based upon the weather projections, it can actually tell how much to irrigate, when to irrigate, and when to stop irrigation. So this is just an example of irrigation. And same thing is also the one which I mentioned to you before, is also used for fertilizer implementation as well. So there's a lot of these digital and AI tools which will be used. In this particular program is called Space to Place. Space meaning using satellite imaging. Place meaning using your own field as an example. So that's that. And then weed management. Again, weeds cause significant yield losses. And if you don't manage your weeds appropriately at an appropriate time, herbicide use is one option, but overuse of herbicide because weeds are not equally there. You're applying too much herbicide. Now this John Deere has come up with a technology called See and Spray. So you can put cameras in front of your tractor, and they especially first identify whether it's a weed or a crop plant, and then density of the crop plant, and whether it is a dicot or a monocot, and then apply that particular herbicide through those nozzles so that it only applies, kills those weeds. So that's called See and Spray technology. And then there are some people have gone beyond that because you're still using herbicides, right? So people are saying see, and there is a sensor lasers. It just kills that weed. So no chemical use. So there's a lot of those technologies are coming up in weed management. And of course, pest management is a big issue. Now you can give cell phone. Most of the farmers have the smartphone. They can take the image of the symptoms of what they're seeing, and that image is loaded into the cloud, and it matches with the database there and tell, okay, you have nitrogen deficiency, you have iron deficiency. Now apply nitrogen or apply iron or apply phosphorus, or make sure that this is this disease, so you can protect this by using this fungicide. So there's a lot of those innovations that are coming up because those days are gone. Because every farmer has a smartphone now. Those days are gone when they didn't have access to phone, and now even the internet access is there, and it's becoming cheaper or free as well. So there's a lot of these innovations will be very valuable for the small and the farmers. And this is a company called Plantex, which uses the cell phone technology to match with identify what those diseases and insects are, and then give a recommendation for spray for those particular farmers. So that's that. And also we also use this for predicting the quality, because especially quality is very important, whether it is wheat for protein, or in this particular case, it is soybean, where we want to make sure that oil content and protein content is good. So we're taking the images in the early seed set and the early seed growth and projecting what the quality of that crop is going to be. So that information is because we want to make sure that maintain the quality first, and then also make sure that we're not mixing the grain lots. Because if you mix a high quality lot with a low quality lot, the entire market price will go down. So this also gives us an opportunity to first look at the yield and then the quality, and then do we want to take care of the crop better so that there's higher yields and quality as well. So that's number 9. And the last one is knowledge and information exchange. And this is also from Digital Green, a company. This is farmer, just like we have ChatGPT in the computers. This is farmers chat, but this is yet not using artificial intelligence. But now I think I came to know that in India, WhatsApp is very popular, Telegram and WhatsApp. So everything is happening through WhatsApp. And for me, that's a learning process, because I know WhatsApp is only for communication, but now document exchange, servers on the phone asking you to convert into a PDF and sign it up. I'm thinking, well, I know access. Everything is happening through phone. And this is also a chat farmer or digital way where farmers can chat specifically on agricultural issues. Or if you want to give technology, then you go into the WhatsApp can only take you to a certain limit. But if this is targeted access for that, then it will be a little bit good. So I hope I gave you a fast, rapid, but it gives you at least an idea where we are going. And then before I end or before I close, I do wanted to give you a slide. You may be thinking, okay, are these digital? Are these artificial intelligence? Because those two are slightly different things. So to get to artificial intelligence, we need to make sure that we are first digital, because the artificial intelligence use data. And then if there is enough data, it makes a trend. And of course, there's multiple components of this AI. There's simple AI, there's intelligent AI, and there's next steps of the 3 layers of this AI. But right now, first step is that using it for a particular target. All the information which I gave is AI using for a specific purpose, whether it's for planting, irrigation, fertilizer, pest monitoring, quality or not. But next step is going to be bigger. And then final step is going to be, it does not need human intervention. It will learn itself. So that's where artificial intelligence is going, but we cannot go at AI before we go digital. So there's a link to that. We are not there yet. Artificial intelligence is providing opportunity, but it's not there yet for agriculture. unlike in the stock market or unlike in the defense system, there is a lot of happening, but I do believe that in the next 2 to 3 years or maybe next 5 years, we'll see a revolution of digital tools first and then artificial intelligence taking over. And because it's for human eye to capture that is going to be a lot very tough. But AI can capture it rapidly, whether it is gene editing, whether it is phenotyping, so whether it is target precision applications. So there's a lot of options. I'd like to conclude here by few of these points. Agri-food systems are complex and we have many challenges, and solutions require systems approaches and out-of-the-box thinking. And our innovations and technologies should be productive, profitable, resilient, resource smart, nutrition smart, and climate smart. And then focus should be on producing more nutritious, safe, and healthy food from existing farmland without damaging, with emphasis on rebuilding natural resources and climate resilience. And research and emphasis on digital and artificial intelligence tools is dramatically increasing, and it will be transforming our agri-food systems in the next few years. There are many available innovations on SAI or sustainable ag intensification, digital AI tools as shown, but focus should be on accessibility, adoption, and scaling, and transdisciplinary and convergence of biophysical and social data and computing science is needed. And at the end, effective partnership between the public and private sector is key to success for developing and scaling these innovations to the point where it can have a positive impact on food, nutrition, climate, and soil security. With that, I would like to end, and I would like to again thank Honorable Vice Chancellor Dr. K. Gopal Garu, and also International Program Director Dr. Dhananjay Rao Garu, with compliments from our President Richard Linton, and our counterpart to you in Associate Provost of the National Programs is Dr. Grant Chapman, Virginia Sukuna Bhavantu, and thank you very much, and I will be glad to take any questions.
Thank you very much.
The examples are very nice. Innovative examples for different users.
Sir, thank you very much. Excellent presentation. And I have cautioned 828 million people are not access to food, 2 billion people are malnutrition, and set of goals of 15% growth. And nowadays the diabetes and cardiovascular disease are increasing. And systems approach, socio-economic, agroecological, genetic approaches, intensification. And we are present in 14 countries to produce scores. And speed breeding technology, your stress, traditional breeding, shuttle breeding, speed breeding technologies, and express edit technology and farming systems, wheat, rice, and climate resilience, nutrition, biofortified nutritional crops, and stress tolerant varieties. African varieties are more drought tolerant stress, and doubled legume, this one, and agroforestry systems, perennial rice, wheat, and sorghum. This is one of the area that perennial crops, rice, wheat, and sorghum. Conservation of agriculture practices, solar powered drip micro irrigation, integrated pest management, biomolecules, nanotechnology, naval social and communication platforms, artificial intelligence in horticulture from land area, and weed management, fertilizer management, pest and disease management. So digital and agriculture, artificial intelligence tools, and so you covered everything, geopad agriculture, and soil and land mapping, seed mapping, variable rate of applications, drones technology for the identification of the growth and health of the crop, irrigation, soil and space. So everything, pest and diseases. So everything you covered, sir, and artificial intelligence and digital and intensification technologies in agriculture and horticulture. Thank you very much, sir. Excellent presentation. Congratulations. And now it is open for discussion. Any question and answer, please.
For those of you who are online, please type it in the chat box, and then either I can see it here or someone can translate. Yeah, that I can say. It's difficult to read. Maybe you can help me with one second.
Any question and answers from the audience, please?
Good morning, sir. Good morning, sir. I'm Doraji Rao, Associate Dean, College of Horticulture, Venkatramanagudem. Very beautiful presentation, sir. Thank you very much for being here with us. And I would like to request you useful information for the students. Some of the students these days, during their final year itself, they are trying to have admissions into foreign universities. And there are a couple of students who are successful also. So in this regard, even if not on the spot, at least later, just we want on behalf of university for the colleges, the probable admissions are the people who would like to offer opportunities for the students, because most of the students, they are consulting some consultancies, and some of them are directly approaching the universities through their kith and kin. And these are the things which are happening. But officially, we have a little information whether some of the professors from XYZ university can give some opportunities to the students for their MSc or advanced research. So in this area, my earnest request is on behalf of your university, if there is any information, kindly share it, sir, or throw some light on this particular aspect, sir. Thank you very much.
All right, thank you very much. This is more of a, not a technical question, it's more about the students and opportunities and what are the generic rules for admissions into US universities. So I can certainly tell you that some of the key requirements for the students where they can directly approach the university. Each of the university or within that university, each department has somebody called as graduate coordinator. Whether it doesn't matter if it's Kansas State or any university, wherever the students are trying to apply, there is a graduate school, which is more for the entire university. And there's also a graduate coordinator, which is at a specific department. If the student knows which college and which department he or she is trying to get admitted, so there's that information there. He or she should reach out to that graduate coordinator and say that I'm interested to apply in the fall or a spring semester for a master's or a PhD degree. And this is my area of interest. Do you have any graduate student research opportunities, which provides GRA, graduate research opportunity, or GTA, graduate teaching opportunity? That's the first step for the students. Rather than going through there are consultants who can help, but this is one in the ways to approach directly. And then once they are in connection with them, they will provide the information of application, where to get the application, how much is an application fee, and what are the critical components for getting admitted. Basically, there are three requirements. Number one is TOEFL or IELTS equivalent, that which is an English proficiency. Number two is GRE, which talks about the technical skills. And then the third one is statement of purpose. Why do you want to be admitted in that particular university, in that particular college, in that particular department, or in that particular specific area? So these are the three minimum requirements. You should have written these three and then have your CV and send it to that person. So that's that piece. The second is that most of the time you can also, GRAs are also advertised in those universities. So they say that this professor is looking for a GRA or GTA and this many openings, and then you can apply. So that's a generic process. And a specific question about regarding that, can a professor provide specific admission to your students? We are equal opportunity. We provide equal opportunities to everyone. So that all universities in the US, specifically us, we are equal opportunity providers, meaning that everyone has equal opportunity. we don't show discrimination. So we say that there are 5 GRA positions or 5 graduate students. It's comparatively awarded to that particular student, whoever is the best, whoever is qualified in the best, whether it's national, domestic, international, then that doesn't concern. So that's the thing. But if you meaning that university or a donor or anybody else specifically say that we have funding and these are the competitively identified students, can you provide an admission to them? Then we'll look at those criteria. If they have their IELTS, if they have GRE, and they have a good GPA, it is GPA's grade point, then if they meet the minimum qualification, we will be glad to. Does that make sense? Generic process, requirements, targeted funding. You identify a student, you provide the funding. We will give those material to a grad school and they'll follow through. And if there is a specific area where we can say that, okay, we can provide half the funding, can you provide the half the funding? That is individual basis, faculty to faculty. And that discussion should happen at the faculty.
Okay, Doraji, you're clear?
Yes, sir. Yes, sir. That's a useful information for the colleges.
Okay. Next.
Thank you, sir. Thank you.
Anybody from students? Students.
Faculty, students.
Any faculty member? Who wants to have collaborations?
Sir, good morning, sir.
Good morning. చెప్పండి.
Sir, nowadays, most of the farmers are also interested in using drones in the application of the pesticides. Is there any research work, like crop specific research work is going on at your institute? I would like to know, sir.
Well, I think there's a lot of institutions who are using aerial vehicles. And specifically in Kansas or in US, where the land holdings are very big, because we have farmers who have more than 500 acres or 1,000 acres or even 5,000 acres. So they've always been using aerial space, application of pesticides or herbicides or even fertilizer through drone. They're bigger than drones. Drones are smaller, but the small aircrafts, they apply that. So that's always been happening. The question is whether precision application is happening or not, because these are blanket applications. They fly through and then use a specific rate and apply. So that is currently under research, and some farmers who have that variable map of their field and all the crop health, they are applying variable rates, but that's not happening through aircrafts. That's happening through sprays or the booms which are attached to a tractor, where they can have a map, and then they can apply precision application of fertilizer, precision application of pesticides, or precision application of herbicides, and also irrigation. So it's happening precision application, not through the drones at this point in time, because drones and variable rate is going to be very complicated. So drones are, even in India, I believe that drones are primarily using for blanket application, not precision application. When it comes to precision application, tractor or ground vehicle based technologies are the best option at this point in time. Large one, and also because with drone, if you use drone for precision agriculture, then to be first there has to be a spectral image or a digital image, and then it has to stay there. It has to first sense it, that, okay, this is this, and then, right, and then who next? So, and what's the application size of the drone? So it's coming, whereas it's a tractor, you go through and then it can be done. So I'm not saying it cannot be done, but it'll take a lot more research to use drones for.
So needs
Because their precision depends on, when I talk about precision agriculture, I'm talking about square meters.
Yeah.
1 meter square, not 1 acre or 2 acres. 1 acre precision ag, you can do it. Through drones, but when I'm talking about precision agriculture, I'm talking about a square meter, not an acre or a half an acre.
It needs the standardization.
Yeah.
Sirisha, are you clear?
Yes, sir. Thank you, sir.
Good afternoon.
Anybody?
Sir, thank you, sir. I am Dr. Kanaka Mahalakshmi from Mango Research Center, Nijvedu. Sir, in your elaborative and informative talk, very nice. And then, pest and disease management, especially in horticulture crops, in the use of AI, is it possible to first mapping of the any diseases in horticultural crops, sir? That means in my agricultural crops like cereals or paddy, we can easily map the pest or disease infestation in location wise. But is it possible in horticultural crops also like mango, the mapping of diseases or any pest in that area?
Yes, great question. Yes, I think it should be able to do that. And then right now, the best use of digital tools or artificial intelligence is going to be disease monitoring. Rather than disease management, it's a monitoring of disease where they can, based on the humidity, based on the temperature, and based upon the intensity of the spore, or based upon whether it is bacterial, fungal, or viral, based upon that disease pressure, it can predict, right? That predictive AI can be used as a predictive monitoring rather than management at this point in time. Because let's say, for example, the disease triangle, right? I'm talking about pathology. Same thing is also true for entomology. The disease triangle, right? Host plant resistance or environment and the disease pressure. Those three will require. So if you know that, okay, now the disease is in, let's say, for example, in Tamil Nadu, and the wind speed is this direction, and these are the relative humidity. So you know that in a week or 10 days or 2 weeks, it will come to your area. And that's where you can monitor and have a protective or a prophylactic sprays rather than after the fact, right? So that's where your disease monitoring will be valuable. And then the monitoring can be done through modeling based upon these environmental conditions. And then once there is enough data, then AI can come over and say that, give you a more precise location where this particular disease pressure can be coming. Yes, and I don't see any reason not be able to do that for horticulture crops. If you're able to do that for grain crops, you should be able to do that for horticulture crops as well. Especially when we talk about horticulture, I'm talking about how do you call this? Farms, right? Large farms, commercial horticulture crops, not mangoes in your backyard. So that will not be possible. So whenever there is a commercial horticulture crops grown, then you know that it can be controlled. Whether it's mango plantations or cashew or coconuts or anything, you should be able to use predictive modelings to know when this disease is going to come in. And then management will work. But again, the importance is going to be, you need to have a database, yearly database, saying that this region, this year, this was the pattern, this was the pattern. So continuous monitoring and data collection and open access. Because if you're a pathologist, you always have notes that, okay, this disease was this much in this year, but it's in your computer. Next year, if we are transferred, there's that information available to them or not. So not only collecting, but also digitizing that data and making sure it's accessible to others, and then accessible to the data scientists to modelers to make sure that they can use that information. So it's a multiple step process, but I don't think that it should, horticulture crops, it's difficult. Maybe it's difficult, but it's not, it's definitely possible.
Thank you, sir. Yeah, we are trying on the weather modeling and preparation of forecasting models in horticultural crops.
That's right.
Thank you, sir. Thank you.
Good afternoon. I am Dr. Karunasri, Professor Extension, sir. Sir, any successful approaches for building the social capital and increasing the digital literacy among the farmers, sir, especially in our Andhra Pradesh scenario?
Yes, so great question. So I think it's an excellent question because technology is not a technology if it is not adopted. So with that statement, I would really like to say that I think building social capital is very important because if you look at there are two things, right? Biophysical innovations and social innovations. And when we talk about social capitals, it is those organizations, the small organizations, whether it's a women farmer organization or a commodity farmer organization or youth groups or anyone who's engaged in the processing industry, storage industry, everything else. So social capital is very important. We often talk about human capital, which is degrees, short-term training, long-term training degrees, but collective action can only come from social capital. And I think there's enough literature or enough research done specifically on sustainable intensification. As I mentioned to you, this term was coined by Professor Jules Preddy of University of Essex. So he led a research paper. Don't get me. It's about 2018. But you can look at it. I can share the information. So first, what it did was we wanted to look at what is the current status of sustainable ag intensification around the world. Sustainable intensification. We looked at 7 or 10 technologies, some of those which I mentioned. What's the current status? The research showed that 9% of the land area is currently using some form of sustainable intensification, which is a significant thing. So 9% of the land area in agri-food production is using some sort of sustainable intensification practices. We looked at specific 7 areas. That was part of the deal as well. So that's that piece. And then the second thing is why those were successful. The main reason, I think it was, I hate to quote because it's being recorded and I don't want to give you the wrong numbers, but I think it was significant. If you look at it, they the same time period, last 10 years before 2015 or so. So the same time period, we looked at what caused this increase of those SI practices in 9 to 10% of land area. The significant relationship with the increase in the social groups. So at that time, there was only 500.5 million of 500,000 social groups, and that increased by 6.5 or more. But don't quote me on the numbers. There was a significant increase in those numbers. So the increase in the SI practices adoption was directly associated or indirectly associated with the increase in the social capital, especially the working groups, so that farmer groups. So there is a direct relevance. So I think it's having a technology, but making sure that it is reaching an adopted by these social groups. Investment in social capital is very important, more than so than the technical innovations. There is no threat of technical information. We all know that there's so many improved varieties, so many improved management. Adoption is an issue. So we need to understand what are the barriers for adoption, what are the policies required, and then access to that knowledge, and then removing the barriers of adoption should be the focus. So social groups play a significant role in adoption and scaling.
Thank you, sir.
Thank you, madam. Anybody?
Sir, I have a question, sir. Hope I am audible.
Yeah.
Sir, you have covered everything like traditional breeding, shuttle breeding, and speed breeding. I have a question regarding horticulture crops. As we have very primitive information of horticulture crops in respect to the greenhouse conditions, we don't know much information. What are the standard of practices for like turmeric or ginger, which are in a primitive form of research? Then what will be the better strategy for research under speed breeding?
Yes, thank you very much. Excellent question. Speed breeding for horticulture, perennial tree crops is not going to be possible. I want to acknowledge that because you cannot grow them in a grow chamber, we can probably grow them in a greenhouse conditions, but in greenhouse conditions you can control the temperature and the humidity, but it's very difficult to control your daylight, which is photoperiod basically, which is very important for speed breeding. So for vegetable crops, which are not that tall, that is possible. Your ginger, turmeric, which are root crops, it is possible, but it will be very difficult for coconuts or mangoes or citrus or any of those things, because unless you have a huge facility, which is not going to be economically viable as well. So under those situations, I think having them growing in a greenhouse conditions where instead of growing 3 or 4 generations, you might be able to grow 2 generations. It will still cut down the time for using traditional field crop where you can only plant once because of the environmental conditions. So using greenhouse technologies, I'm not talking about greenhouses. I'm talking about greenhouses where you can control the temperature and the relative humidity, and you can control photoperiod by having curtains open and close up. But that's a lot labor intensive. It is possible, but for tree crops, it's difficult. So we have to come up with alternative approaches, and there are alternative approaches available. So, for example, tissue culture techniques is one good way to. It's not speed breeding, but it is tissue culture, and use the transformational tools can at least minimize the time from planting to maturity. And tissue culture is very common in all of the horticulture crops, because horticulture crops, breeding has always been done through tissue culture. I don't know specifically for turmeric and ginger, but obviously for bananas and many other tissue culture is a very common technology. And I would not call it. It can be categorized as a speed breeding because they are increasing the generations rapidly. In this case, we are using hormones or the growth regulators for that matter. So that's a possibility.
Thank you, sir.
Good afternoon, sir. Sir, I have a question. Sir, you mentioned so many apps which can be accessed, but are all those apps accessible to all the countries, or are they country specific, sir?
No, no. As I mentioned to you before, it was just as literature an example. But again, accessible, yes, because it's down on an app and you do it. But whether they can, it's a paid service, and all the things which I was talking about, John Deere or Geopard, those are all paid services. Meaning that I'm not sure if the smallholder farmers of AP or some farmer in Africa is going to be used, especially if it is a paid app. But if it is a non-paid app, which is free for them to use, as long as they're using this app for data collection and they have their counter agency, whether it's ICR in the Indian Council of Agriculture Research for India or Krishi Vignan Kendras, or even your own university, where they can collect that information, farmer can collect that information, but you provide that services as a part of your organization, either free or as a normal charge. So those type of services needs to be identified. And I think nowadays it's not a development of app is very easy. It's not a difficult thing. Again, making sure it is giving you it is calibrated well, and it is giving you the right information, and it has to be tested, and it has to be tested in a particular geography. So there's a lot of subtlety to those, subtlety to make sure that that app is actually a viable solution for your own region. So it'll boil down to, you think global but local, act local, right? That's a terminology which we need to use. That yes, these apps are like satellite images are available, but how can you convert that satellite imaging to a local management is very critical. So that's where the university research and students as you will be very useful, because you can take this app, if it is a free, download it, and then see if it works for your community in a particular crop or not. So you'll have to refine it, and then if you have data scientists, you can develop your own app, which is very locally suitable.
Thank you.
Thank you, madam.
I have a question. Sir, some of the companies they are manufacturing mini robots towards against pest control.
Yeah.
And in this regard, laser technology also they are developing. What's your opinion on this, sir? Is there any in future?
Yeah. Absolutely. So I think, as I mentioned to you, that because I mentioned in the laser technology when I was mentioning about see and spray technology of John Deere, where you're identifying or separating the crops and the weeds, and you're spraying a chemical. Instead of that, you can use a laser to kill the weed as well. So I think I'm glad that you brought up the robotics issue. I think robots are the future. I really mean it. I really mean it when I say because if you look at this mechanization, which is happened around the world, especially in the developed nations, which is large scale. The combines or the reaper. I mean, I know that even the harvesting now in AP is happening through combines or small combines, which is good. But I think when it comes to diversifying this, robots are the future because robots can be scale neutral. What do I mean by that? If we have a farmer who has 10 acres can have 10 robots. A farmer who has 1 acre can have 1 robot. So it's a scale neutral. Small farmers can only buy 1 robot, whereas a large farmer can buy 10 or 100 or 1,000 robots. So that's going to come. But right now, what is prohibiting is economics, right? So, and it's the same thing. Large scale mechanization is also not very popular is because of the economics. Right now, how do you address that is through service provision model, meaning that you have a youth who can get a loan from the bank and buy a harvester or a combine and provide a service to all the people in that, all the big farmers or even small farmers for a fee in that community. So I would see that as for use for robots as well. So they can have 10 or 15 robots and then they will loan them out or even provide that type of service. So that's possible. And laser technology, yes, it is there. And laser technology on top of robots, it's perfect for site specific, especially for if you want to kill anything. And especially, I'm assuming you're talking about laser technology for weed management because it can go and it can just kill that particular weed. And then there is a lot of information on that. So it'll come. It'll come because but again, for economics, that is development of that laser technology cheaper than hand weeding, cheaper than your chemicals. So that economics is the one which is going to drive the adoption of technologies. Same thing, same response as the previous question related to app. If the apps are free, if they are correct, and if they can be utilized, then people are going to use it. But if it is going to be too expensive, then they're not going to be successful. And apps also, I think it's not a one-time deal, right? Every time you take a picture, people will find ways because the company who has developed and the person who has developed also needs to be economically viable for them. So yeah, so it's going in the right direction. But
these are the technologies, yes. But and again, it's their use. Are they affecting biodiversity? Are they affecting human health?
Yeah.
So probably these are the things needs to be checked before.
Yes.
Because nowadays we see one advertisement, some drone type, it comes and it hits the pigs will die. So it's coming frequently that one advertisement. So here, okay, pigs, and is it identifies the pig and again then it uses that lasers or blanketly it goes?
No.
If it's only pig, what about if somewhere it's nearer to that? If it is a dog, it can kill a dog and a pig or only pig.
Yeah.
So probably these are the things we should see to safeguard the biodiversity.
Absolutely.
So it should be laser should be very specific. It is broad means again it may affect biodiversity and also health of the human beings.
Absolutely. I think when you talk about laser, I think these are low intensity lasers. Hope and assume that it's not going to kill any living organism. It's just the plant at a very seedling stage and very small stage, and it's targeted because you kill the growing point and it's dead, not the whole. Okay, so but of course your concerns are relevant, and obviously I'm assuming that technology or the robots which have this label can differentiate between a between a living animal versus plant. At least that it can do.
Yeah.
It may not be, I will be more worried whether it will kill the thorn or the mango tree versus this. So at least it should have the technology to differentiate between an animal and a.
Yeah, targeted
Right.
usage.
Targeted waste.
Okay. Thank
Thank you,
you. Anybody?
Sir, one submission, sir. I'm Dr. Chalapati from University Museum, sir. Sir, you have highlighted and we have clearly understood the importance of digital agriculture. Sir, can you kindly guide us how we can equip ourselves now? Because we came in an era we have studied 22, 25 years back, and as technology is advancing very fast, can you kindly guide us, sir? We can equip ourselves through online by pursuing any online courses or in-person courses at any of the institutes so that we get tuned to the next generation.
I'm pretty sure there's a lot of those, and I think choosing the right course is going to be very critical. And also because nowadays I think it's important who trains you on what and when and relevance of that, and then is that an accredited institution? And as it comes, are the teachers really the experts in that area? So there's a lot of things which you need to be thinking about. And again, I'm not sure there are how many are there in this particular West Godavari district or in Andhra Pradesh or Telangana. But I think whenever you're talking about training on especially these new innovative technologies, right organization given by right people and with an approved accredited certification is going to be the key. Because I'm certainly does not claim to be knowledgeable about digital or anything to do with AI. So there's much more known scholars who can do that. Of course, there are courses, short-term courses, whether it's a certification course, and especially in the teaching, I think it'll be very important. You at least have introduction to digital agriculture, introduction to artificial intelligence, to introductory course in our undergraduate programs or graduate programs. It is relevant, and then when you come to advanced master's program, then you can make sure that there are a little bit more depth. And then when they choose their research program, if they're targeting their research problem and thesis research on that, you probably need to make sure that collaborating with an appropriate organization. And it may not be Horticulture University or Agriculture University. It could be a pure science or a data science university, whether it is Indian Institute of Technology, NITs or IIScs. So you want to make sure that you are bringing faculty from there or sending your faculty trained at those well-known organizations, whether it is the IITs or IIScs or NIITs. So make sure that it's done.
Yes.
Thank you,
So
sir. Thank you, sir.
I have one question, sir. Sir, myself, Dr. Manuel. Sir, this is regarding this agrochemicals. Because we have a lot of issues agrochemicals in India, because India is one of the leading country in using agrochemicals, sir. But one way we want to give the latest recommendations in terms of latest molecules to the farming community. But at the same time, we need to preserve this biodiversity and we need to go for natural farming or biological control aspects even. So in terms of AI, ML, do you have any kinds of algorithms supporting, the resistance management aspects of this dirty toxins? Because we need to be careful with this resistance aspects of most of the agrochemicals present in the market, sir. One issue, sir, about this agrochemicals. And second thing is, do we have any alert systems of using this excessive use of chemicals, where in most of the advanced countries, they are limiting the chemicals, but whereas in India, we are still using these toxins, sir. So can you help us in making some policy matters regarding this agrochemicals?
Yes, again, very important and a great question. I think first I would answer your second question first in terms of how do you have policies making sure that we are not overusing pesticides or I'm using a broader terminology of pesticides, which includes herbicides, which includes fungicides, and also some of the chemical space which are used in agri-food systems. So I think oftentimes when you talk about resistance to pesticides, whether it is a pest or the host plant, same thing, whether it is a crop plant or whether it is a weed, which is a serious issue. And generally this comes by overuse and indiscriminate use of chemicals. Therefore, it has the proper training, and then appropriate use of these chemicals is required to make sure that we avoid the disease resistance of the disease itself or the pest itself, and same case for the weeds and the plants. So there has to be a policies and training, and also it's not just the policy, right? Implementation of the policy is important. We have policies. Name a thing. There is a policy there. Whether that policy is implementing or not. That's number one. And then if they are not following the rules, is there any penalty? Because, okay, there is a policy, it's being implemented, but what's the cost of non-compliance? So there has to be that. So I think that, therefore, I think it's more about stewardship. How do we steward the farmers to make sure that they understand that herbicide resistance, just picking herbicides as an example, herbicide resistance is an issue. So they need to be taught that you have to rotate your pesticides, you have to rotate your herbicides, just the way you rotate your plants, and then make sure that you are, and also alternative chemistries, because there are multiple chemistries which same pests or same weed can be controlled by multiple chemistries of the herbicides. So there, that stewardship is done. So, and obviously, yes, you're right. We are using more chemicals or more pesticides than what we needed because farmers want to protect it. And one of the reasons why they want to do it is indiscriminate or blanket application. So that's where your precision application of pesticides or herbicides is going to be key. Is that you're not overusing, and more importantly, one of the major cause of what you were talking about, loss of biodiversity, is this runoff of these pesticides into our water bodies or into our ecosystems, and that's what it is killing, right? So therefore, you need to make sure that overuse and excess, right time, right place, right amounts, those type of needs to be done. And then also let's go integrated, meaning that integrated weed management, integrated pest management, meaning that combinations of chemical and non-chemicals, where those non-chemicals are rotations, or biologicals, or something, or even bio insects, biopesticides, right? Even predatory pests can be released to control the normal pests. So the integrated use of chemicals and non-chemicals should be part of that. So that's about the excessive thing. And then before that, your first question, I forgot to write it down. What was that?
It is dealing with how do we write an algorithm or to find out.
Yeah, algorithm and use of AIs in terms of development of these resistance and that. I'm not aware of that. I think we are not there yet. We are not there yet to use AI to say the potential development of pest resistance or herbicide resistance of weeds or plants. We are not there yet because there is not enough data available to use this information at this point of time. That's my limited knowledge, because I'm not, again, I'm acknowledging and saying I'm no specialist in digital tools and no specialist in AI information, but as far as I know at this point of time, that is not there yet, and I wouldn't be surprised if it will come in the next few years.
Okay, Emmanuel.
Yes, sir.
Anybody? Almost 3 hours is. Okay. If nobody is there, I will invite our registrar, Dr. V. Srinivasulu, to say what of thanks.
Okay, thank you, Dr. Dhananjay, for giving me the opportunity to propose formal vote of thanks on this 25th Global Connect Series talk given by Dr. P.V. Varaprasad Garu, the distinguished professor from Kansas State University. Sir, at the outset, I would like to extend my heartfelt thanks to our Honorable Vice Chancellor for giving permission to conduct this Silver Jubilee talk I think I can,
Yeah.
because this is the 25th.
That's right, that's right.
That way this talk will be remembered.
And again, on foundation.
On Foundation Day. So this is
That's
going to
right.
be a specific talk. I think I can say, we are all very thankful to our Honorable Vice Chancellor for giving us the, chance to have this program today. Happens to be the auspicious day, the formation of Dr. Y.S. Horticulture University. And we immensely thank Dr. Varaprasad Garu, the distinguished professor from Kansas State Agriculture University, for giving an excellent talk. I think he has really taken us to a new world of sustainable intensification. Some new technological, ideas were given in the context of food safety and agri-food systems. On behalf of our Honorable Vice Chancellor and all university officers present over here, and all the our staff members, students who have attended this program online, we extend our heartfelt thanks to you for giving us an excellent talk and very informative talk. We are very much thankful to you, sir. And it's almost a 3 hours program. I think very, very useful program for us.
So the excellent overview.
Yes, yes.
Overview about sustainable intensification, digital
Getting all of, I think
all suitable examples.
with suitable examples we are given. Really very, very thankful. I think we request you to so kindly, I think, to make some time to give us some scope to interact with some other persons, eminent personalities working with you there through online program whenever it is possible, and also the exchange of students and staff. Particularly, this program is intended to have that. In that aspect, I think we are all our staff will be looking for that one. I think this program will definitely make sure that because we have entered into MOU also today with one of the, the very reputed organization and personality also, the eminent person.
Like first land grant.
Land agreement. Yes, land grant agreement.
1918.
1918.
1890.
1860.
Yes, yes. I think we are lucky to have you here.
And that is the university which started land grant institutions in India.
In India, yes. And you are going to, I think, happen to be our alumni also. Really very, very thankful to you, sir, for giving an opportunity for you to spend, the 3 hours time with us and sharing your knowledge with all our people. And once again, thank you, sir. And I'm also thankful to all my colleagues here and all the associate deans, associate directors, principals, and all the faculty and students for being with us, and also for your queries. I think all the queries were, their doubts were clarified. And thank you very much for your participation. Thank you.
Thank you, sir. Thank you, Ananda. Now the program is closed.
Thank you, sir.
Thank you, sir.